I'm going to try to record as many sessions as I can. We started working on we are applying this agile approach that we said we'll be applying, and we'll spend a fair amount of time discussing Scrum. But for now, I want to practice this approach, this iterative approach, using a very simple example of the Fibonacci sequence or series. First is, of course, understanding what it is, the analysis of requirements. And once you've understood it, the second is a simple design. And we discussed the signature of a method, in this case, for designing this particular functionality. The third piece is actually writing the program. The fourth, testing, and the fifth is releasing it. And we started this step of starting to write the program, and I asked you to name it first MVC app last name, and obviously you have to do it from within Visual Studio. And there are multiple, well, two ways of opening up projects. One is going from within Visual Studio, go to Open Project, and go into your application. You should be able to see the solution file and open it up using that. So that's one approach, to which is usually the more reliable approach. The other approach is to scroll through or go into your solution, into your folder, and then find the solution file. So I had saved this over here, and from last class, most of you said you either had a laptop. How many of you have your laptops? Yeah. Pretty much. How many are working on the lab computers? 4 of you? Okay. 5? Okay. So the 5 of you who are working on the lab computers, do you have Visual Studio someplace at home? The lab itself will be closed on weekends, and I think, I don't know, has anyone checked the Atrium computers? Do they have Visual Studio on it? They don't? They don't? Okay. So you need to have some alternate way of, so the 5 of you, do you have a desktop, a laptop accessible at home where, okay. So anyway, so it's important that you have access outside of the lab to Visual Studio. Later on, you'll get into SQL Server, which will also be helpful if you have access to. Okay, so once you've opened it up, you're going to see 2 projects in it. One is the MVC application, and if one of you told me that why it is called MVC, who is it? Was it Kash? Okay, what? Can you? Model view and controller. This is called the 3-layered architecture to design development. It's existed for a long time, but Ruby on Rails put it together. Ruby on Rails, iOS. Now pretty much every application is developed this way. So you have M for model. And even though it's called MVC, the order of how it flows is not quite that. It's actually the C comes next, and the V tends to be Okay. This is how the interactivity occurs with the user. So you have different layers. So one is representing the data. The second represents the business logic, and the third one represents how the user interacts with the application. So of these three, which do you think is the one where the user interacts? When we say user interacts, what does it involve? The user interface, the input and the output. Which of these three do you think represents the user interaction?
The view.
Okay, the view. So this denotes our interaction. This is the this is the user interface, the user interaction layer, and this, what do you think this denotes by its name, controller? One mainly deals with the user interaction, which is the view. I told you there are two others. One is data, the other is the business logic. So what do you think the controller deals with, the data or the business logic? Are the others involved? Data. Data. The controller, what does the controller seem to indicate?
I guess business rules.
It's the one that controls the flow. So it is the business logic or the business rules. That's where you're going to find it. And the word in business logic. And finally, the third aspect of the system deals with the data. And we are going to use a relational database, and it's going to be a SQL Server. But with MVC, the data is going to reside in a relational database, but it's also going to get represented as classes in the model, and you'll get more into it. For this example, it's much more, it's a simpler example, so we won't get to see, well, how it connects to the database this time. But as we get, so for this first example, I just want you to get a sense of how these three layers work for a simple case, and then we'll get into a more involved example with the database. I want to do a quick sort of a poll. Last semester I used a student registration system, which I'm continuing to use for 452. For 353, I've used something like, was it vehicle service or something? Well, this time I've been trying to figure out what application to use. How many of you like, let's say, college basketball? Okay. So is it off the class? Okay. Is there any other applications that anyone else is interested in? Obviously, it cannot be a project, something different from a project. Okay, so college basketball will be for us to explore. So that's what we'll use for the bigger application. But for now, we'll work on this smaller one. Okay, so I'd asked you to look at creating this method. Well, to start off with, I asked you to set up the signature of this method. Okay, so that's the first thing. I'm going to come around to check what you did, each of you did for the signature. Okay, and how do you set it up? Well, you have to go into a class. I asked you, how many of you actually created a class inside of Visual Studio? Only Logan? Okay. So if you didn't create a class inside of Visual Studio, well, what did I say? We are going to name the class calculator. So, the place where we create the class is inside of this model folder, or models folder. Okay. And right-click on models. It says add. Well, it's one of the options, and you can add a class. So your model represents your data repository, and the data repository is going to be, you're going to indicate that with the set of clauses. For now, as I said, it doesn't go to the database. You're just going to set everything up just inside of Visual Studio. So when you create your class, we're going to create this class as, I'm calling it calculator. Okay. This should be familiar to you, right? You worked on, I think in 352, did you work on console applications? Did you create anything with a user interface? Towards the end, did you move from console to any other type? No? Okay. Okay, so, but the basic concept is the same. So you have the class created here with the same name. By the way, what is this here versus this? Are these two the same? Do they always have to be the same? What is this here? What would you call this? You call this a class, right? What is this? It is just a file. And you can name a file anything you want. But usually if there's only one class, you would name the file exactly the same name as the class name. But there are some cases where you might have multiple classes in the same file, and then you wouldn't obviously name it just by one class name. And you'll see that when we go to more one of the MVC applications that we build in. For some of the authentication authorization purposes, you actually have a larger one file containing multiple classes, but that's something very basic to keep in mind. How many of you know what this stands for? You've seen it many times, right? So what is that, Megan?
Where your project is stored in the namespace for you to call upon it.
Okay, so when you say project is stored in the namespace, you can see the namespace actually comes from the solution itself. And then within the solution you have your project, and within the project, the place where you get this models is, it's almost like a directory structure. Now why might you have, when you're storing, for example, if you're just storing files, if you had two files by the name of calculator, could you store both of them in the same directory? The answer is no, right? There will be a conflict in naming. You have to change the name. And you also would not want two calculators in the same directory if they are doing the same thing. Now, let's say that there is a student class instead of a calculator class. So there's a student class. And this student class, let's say you have it for, you use it for registration purposes, and you might also use a student class for financial aid. Now, these might be, if you're using it with two different objectives in mind, you might have a student class under a namespace called registration, and another student class under the namespace called financial aid. So by having two different namespaces, if there's a conflict in naming clauses, you can always solve this by using the dot notation. So how would I call the clause from the registration application? I would say, Eric?
Namespace, students,
Yeah.
registration.
Well, it's going to be the namespace dot the class name. The namespace is the higher level, right?
Okay.
So if you're looking for a file inside a directory, the directory comes first and then the file, right? The same concept here. So what is it? What is the purpose of namespaces? What's it helping you do? Liv, what's the purpose? I just gave you an example. You can reference one student class. Let's say there are two student classes. This one student class can be referenced by saying registration.student. How will you reference the second student class?
Your financial aid something.
Yeah, financial aid dot student. So what's the purpose? So looking at this example that I just made up, what do you think is the purpose of having the namespace?
Mapping the correct element.
Mapping, okay, but even more fundamentally, basically, why do we have it? TJ?
Avoid redundancy.
Avoid?
Avoid redundancy.
Not quite, because each of them is a separate, there's maybe two different groups that have developed these applications. So you do have two separate student classes. Okay? So it's not quite avoiding redundancy. What's it avoiding?
Just so you don't have to type out the whole thing every time.
No. When you have two, let's say, student files or calculator files, what do we need to do here? They are containing, you created them for two different purposes. They might have some commonality, but you have two purposes, so you have them, you've named them the same. So what did we say? You have to put them in two different directories. So what are we avoiding by putting them in two different places?
Keep them separate.
Okay, you're keeping them separate, and so you're avoiding what? Conflicts, right? So this provides a means of avoiding conflicts or ambiguity in how. So if you didn't have that prefix of a namespace, when you said, I want to use the student class, will the system know which of these student classes to draw upon? The answer is it wouldn't. So for smaller applications, namespaces probably don't matter, but as your applications start becoming larger, they do start mattering. Okay, especially if you develop it for, like, Plus Consulting is currently working on projects for UPMC, and they have literally thousands of applications. So in cases like that, you absolutely need these namespaces. Okay, so that's your background. But coming back to what you needed to do, what was the next step that you needed to do? And I want to see you do this. So what will you do? Write it out. You set out the signature for your method, right? Okay. So what do you do?
I use Visual Studio a lot of content data as Visual Studio, but it is really opening examiner and camera that's going to and I can't really I can't really get out of that.
Okay, go to the task manager. Go to control alt. Well, then on provision said go get into lesson. I want you to work inside these garages with the bottom. Okay, see this is where I expect you to look up I record this, you'll have to, it's an NBC application. Go through that. You'll have to call it by a particular name. It's a first MVC application, your last name. Do you have a thumb drive? Well, I'm going to set the task for you watch the recording, figure it out, because I'm not going to lead you through the process. You can serve that last class. How many of you didn't set up the web application? What I'm looking for is a signature. I want to see two of you, Logan, and we have signature methods of the method, the one method that we'll be using now. You don't want to call it fib. Fib is the lie. Well, one of the things that I want you to use naming conventions. For whatever reason, I think going back 25 years when memory was expensive, computer scientists used to shorten everything to these really short abbreviations. In MIS, we sort of emphasize connecting to the user or the business needs. So I want you to name it like something like find Fibonacci number. Okay. You're creating what type of applications?
How do we get to something?
Okay, what does a class contain? There are two major things that a class contains. What are they? Okay, variables which are you can call them various types of variables. So variables specifically that you find inside a class, what would you call them? There are these two types. Methods for sure. What do methods do? This is Ashley's answer. So what is the purpose of methods? Okay. Do something. Okay. So do something. So all the actions are taken through the methods. The variables are, and inside of a class, is there any specific name given to a variable that you see in a class? Yeah. Okay, there are various names. One is, this makes it a little more specific, instance variables. You could have variables that instance, let me ask you this, instance can be contrasted with what? Instance, what's a synonym for instance? When you say what type of programming are we using now? Object-oriented. So far we have looked at class and you have mentioned instance. Where is the object coming in?
And instance and class is an object.
Exactly. So what is the synonym for instance? Yep. So these can also be called instance or object variables. And so you have instances or objects of a class versus the class itself. So when you say variables, they can be instance variables as well as, put this outside. You could also have variables that belong to the class. Okay, so class, they're also called static variables. Okay. And so the same categorization applies to methods as well. If you have object methods, if you have class methods. Okay. So right now we are interested in this method that finds the Fibonacci number for us. Okay, so we said we are going to have a method that's named find Fibonacci number. Okay, and we said that there are various characteristics of it. So we have a method name, and we have to specify the access type. What's the access type? So that we already said that 99% of methods, a very, very high percentage of methods are going to be public access. Okay, so and all of this has to come within. So one of the things I keep making a note to myself is this is the end. This closing brace is the end of what? It is the end of the namespace. So I'm ending the namespace here. And what does this end? End of what? End of the class. So my method, if you want to put a method, you want to say this is end of my find Fibonacci number method. Obviously, it is saying that there are certain syntax requirements that we are not fulfilling. Whenever you see a method what are the basic syntax methods that we have not fulfilled here? Okay, somebody else other than, who else have I not asked, I guess. I will ask all of you to give me some input to keep thinking. Okay, so I'll come back to Ashley after I go. Gosh, what are the missing pieces? Obviously, whenever you see something like this, it is an error in grammar or syntax, right? So to satisfy that, what do we need to provide? Parameters. So let's say a method didn't have any parameters. What is the minimum it will expect? No, what is the minimum requirement to satisfy the grammar of a method? Okay, good. To open, close. So this is the minimum it requires to see, even if you didn't have any parameters. Basically, we are saying this is a method without any parameters. So at least it satisfies one piece of that grammar. So, so when we talk about method signature, you have to have a name. You have to, well, this is not entirely, it's not a requirement. If I took it out, it would still accept. By the way, if I took it out, what would it, by default, what would it designate it as? It will always, the system will always go with the most restrictive option as default. So what is the most restrictive? It will go with the opposite end. So if you won't designate anything, it will make it a private method. Okay, so, but we want this to be public. Okay, so what else? It's still complaining, so it's not accepting it. What else? Yeah. Okay, if you want the most simplest type of return, what is that? What does void indicate?
It just means you're not actually returning anything.
Okay, if you're not returning anything, so if I want to make the simplest method, it would be this. Simplest method that satisfies the grammatical requirements, right? So it stopped complaining. This doesn't mean that it's logically doing what we want it to do, but it satisfies the syntax requirements. Okay, now let's go ahead and build the correct logic for at least the signature. So we said we want to find, our objective is to find the Fibonacci number for a particular term. So we were saying, well, the user says, provide me the fifth term of a Fibonacci series. We want to return the number 0. If they say, well, give me the 7th term, we want to give the number 8. And so what we have to figure out is how do we design this method, especially the signature of the method, which basically means what are the parameters, what are the return values. Okay, so that's something that we want to design. So that's the design component of this functionality, or this what we are applying with the agile approach here. Okay, so the question is, do we need any input parameter in this case? How many of you have designated input? Result. Okay. So result is going to be what?
Whatever number you're returning. Your next number is
Okay, so if I as the user say I want the, whatever, is it the 0, 1, 1, so if I said I want the 4th number, the result will give me the value 2 then. Yes, whatever that. So, okay. So Megan's suggestion was, and it's a good starting point, what she has is a parameter here called result. So did anyone else have a parameter? I know Eric, okay, Ashley, what was your parameter? Okay, Ashley's suggestion was X. Okay, so instead of result, she used what, and you can see there are two components to a parameter. One is, this is what do you call this? Integer, more generically, a data type, and this is the name of the variable, and then specifically it's a parameter name, a parameter variable. So, so that's why I wanted you to use or distinguish. So these are all variables except that you would call this. So this is a parameter type followed by a parameter name, so or you can say parameter variable name, but it's a specific type of variable used for a specific purpose, which is different from the purpose for which we use an instance variable. So you need to be able to. I don't want to get too caught up with semantics, but you still have to understand the distinction between. So if you just generically say variables, they start to lose that distinction between the different purposes for which they are used. Okay, and Ashley's suggestion was instead of saying result, use X, and this goes back to what Liv had done. She used fib instead of giving something more meaningful. X would be, again, I don't know what X means, right? So if you ask me to use something between X and result, I would go for result. Eric, did you choose anything else? Term. Okay. Term. So on a bigger basis, there's a logical distinction now, right? Earlier, X versus result was just semantics. But what you are suggesting now is logically different from what Megan suggested. Megan is saying she's going to provide the result of whatever you do through whatever the method does is going to be provided through this. What are you saying?
I was just thinking like I'm giving them the term of the Fibonacci sequence that they're looking for. So
when you say term of the Fibonacci, so if I'm looking for, let's see, I'm looking for the 7th term, and the result is 8. So are you saying it's the number 7 represented by your term, or is it the number 8?
it's going to be 8. Or no. I mean, yeah.
Okay, so what Megan is saying is it will be the value 8, right? That this is providing. Okay, Liv?
But aren't the parameters what you use in the method, not the result? The return type.
Okay, so we'll address that. But what Liv is saying is, it's a more fundamental question. What's the purpose of the parameters? And here there are also, and again, as with everything, as you get into it further, there are always layers. But let's look at the simplest case of a parameter. What's the purpose of a parameter? What does it do? Yeah, TJ?
You need that to run the method.
run the method. Not always. We can have methods without any parameters. Okay, look.
So what you're given, and if you aren't given anything, then you don't get to use them.
What are given? Can you make it a little clearer?
Variables that you can use in your method as a means of performing that method.
Okay, so essentially what the method needs to be provided to do its work. There are other means of getting this data too, but one of the main purposes of a parameter is to get data that it needs to use to do its work. So mostly it is to get data to do, let's say, for a method to get data to do whatever its work. And we said that it does something. So for most part, the parameter serves as a means of getting the data in. So in which case, coming back to the distinction between what Megan and Eric had said, the result is something that the method provides. And I said if you dig deeper, you could have, so the main type of parameters are what are called input parameters. But there are, in relatively rare cases, you can have what are called, what's the opposite of input parameters? What's the opposite of input? Output. So you could use parameters for output as well. But in this case, we really are looking to get some value into the method. And I think, Logan, did you have?
I had the input number.
Okay. Input, so we have three options, result, and here we are really not as we are thinking of sending the result back, we are looking at what comes into the method. So, which means the other two you said, Logan, what was your input number and yours was term? Okay, so I would sort of combine the two and say input term, because it's the term that we are looking at getting in. So the user gives us a term. So I'll say input term here. Okay. So I get this, whatever value it is, 1, 2, 3, 4, 5, 6, 7, and what do I want to provide? What does the method do? It finds out what is the Fibonacci number corresponding to that term, and it's going to provide you that number. Okay, so where will that Fibonacci number be provided? And we have two options. One option is to look at what Megan did, and instead of it being an input, it will be an output parameter. But the simpler option is what? Yeah, the return. So you can use this instead of void, it will be a return. Okay, so what will be the return type? Okay. Okay. So now all of a sudden it starts the compiler starts complaining, saying that somehow the grammar of our method, which was considered okay until now, suddenly has gone from being okay to not being okay. What happened? Okay. Anyone else? Let's see. Okay, Hallie. Okay, now. Exactly what Hallie just pointed out. We are now promising to return an integer. And inside of the body of the method, there's nothing saying that it will be something, an integer will be returned. So So to fix this, we'll have to set up another variable inside, and you're Chris, right?
Yeah.
So what would I need to set up inside here?
You need to set up a variable to put the numbers into that the function into.
Okay, so variable. So what? So now we have a third type of variable, or is it not even a third? It's actually a fourth type, right? You have the return type, you have the parameter type, you have the instance variable, and what type of variable is this?
Local variable,
Why is it called local?
because it is only accessible inside of the method to the end of the block.
Okay, it's only this.
Where it's declared to the end of the block.
Okay, so this applies only inside of the method. Okay, so what? How would you declare? So let me go to TJ now. So can you give me a name for this variable? What do we want to return?
Number.
If you just say number, can you? What exactly is it that this method is promising to do?
Return the number 467.
Okay, and what type of number is this?
Is it error or Fibonacci?
We've specified this as a Fibonacci number, right? So we will say Fibonacci. So one of the things I want you to practice is to practice naming, using meaningful names for variables, for methods, and classes. Okay. Okay. So we have the local variable set up as int Fibonacci number, and it's still complaining. What do we need to do? Okay, let's see, Megan.
To fix your red area, you have to have return, and then
Okay, so we are saying we want to return this, and you can see that the grammar, the error that it's indicating went from being here to here. Now, if you hover over it, you'll get some message. So let's see, what was the message previously? Not all code paths return a value. So if I include the return, you are trying to return a value. So it's no longer complaining at the method level. Instead, there is a complaint at the variable, the local variable level. So what's it saying? Somebody other than Megan? Let's see. Okay, let's see. This is a conceptual question. You said your name is Bolaji, right? So what is the reason for this? It's a conceptual one that you should have learned in 352. Tell me if you know the answer to that. Okay, I've not asked, well, whoever not asked, the two of you have not been asking questions. Let me first start with Krista. One of the things I want you to learn to do is to look at the error messages the system is giving you. So what's it telling you, Krista? We have not assigned the Fibonacci number to anything as yet. Is that what it is telling you? it's the opposite, right? We have not assigned anything to the Fibonacci number. So what is the simplest fix for this? Okay, what does that mean generically when you assign? Usually it's 0, it could also be something. What's this called? What do we call doing something like this? How many of you know this? Okay, what's Chris?
Giving a value to it.
There is some more specific term for this. What's that called? What's that? Initializing. You initialize as you declare. It's initializing. So initialize it with a value. This is not necessarily going to be its final value, but you give it an initial value so that it has some value when you say you're returning some value back out of this method. Okay, and it's usually done to prevent the type of error that it's complaining about here. Okay. That it's no value has been assigned. So initializing basically takes care of that type of problem. But obviously you don't want to be returning 0 for any, so if the user gave an input of 0, then this is, well, I guess the first term is 0. The second term onward, this was going to be incorrect, whatever it generates, right? So now we need to get into the logic of what we need to do. How many of you have tried to figure out this logic? Eric, okay, and Hallie, anyone else? Krista, you have the logic? Okay, so you have, can you come up here and explain it? Well, the purpose is not to just give me some code. I want you to explain the logic. Eric, are you able to do that?
Can I do it from here?
No, you have to come up here. Ultimately, how do you, like, one of the things, I mean, I'm guilty of this as well, that we all tend to hold on to something, right? It's sort of a security blanket. And one of the things I want you to practice, or try to have you practice, is pushing you out of your comfort zone. That's the only way you're really going to understand more deeply. So let me have you come up here and go over the logic. And I make notes on where you are, so I'm expecting you. So if you do something like what Eric is doing, that's part of what I evaluate you on, your understanding of what you're doing.
Do you want me to like type it up and everything?
Yes, absolutely.
Okay, so what I was thinking for it is you're going to need at least 3 local variables. The first one being, I guess, Fibonacci number 1. The second being Fibonacci number 2 equals, and I assumed that the first 2 of the Fibonacci sequence will be 0 and 1. And I was going to do 0 and 0, but then the way I did the rest of it made that kind of irrelevant.
Okay.
So
one of the things I would suggest is not using Fibonacci 1, 2. It's okay, I think, in this case, but I would rather go with something like first term and second term or something. But okay, let's go with this.
So like Fibonacci term 1.
Yeah, or first term, like using a suffix of 1, 2, is sometimes problematic, but in this case, let's go with this. Okay, let's see.
Okay. And then the third one would be like Fibonacci result. And I set that equal to 0 just as a placeholder. And then you would need a for loop.
Okay, let's not go into the for loop now. So let's just look at the logic that you're setting up. So what are you trying to do here? Just good luck.
So I'm going to basically loop as many times as the input term that they give us. So, you know, if they want the 8th term, you would loop through it 8 times. And each time that the loop iterates, you add Fibonacci 1 and Fibonacci 2.
Okay. So what Eric has set up here is a pretty good starting design. So one of the things I didn't want you to do was to give the entire answer. I want some of the students to figure it out. That's fine. Actually, you proved to me that you understood it. So that was part of what I wanted to see. So what I want you to do is to take what Eric has provided us as a starting point, and then to build on it, and even gave you that you need to loop through. So let's see you implement this design. And why do you think he asked for Fibonacci 1, Fibonacci 2? What is the requirement of these two? Yes. Okay, good. You want it to be, that's a starting point. Without that, you cannot proceed any further. So they are sometimes called seeding. So you want something seeded to be built upon. So the Fibonacci result is the sum of 2 previous terms of values. So you start with that, okay? So I want the rest of you to take what he gave us and then apply it and show me what you have as your method. Because if you just copy what was up there, then you will not understand. You named it something entirely different here.
Well, yeah, just for keeping it short, something desired.
Okay, so you keep switching it, and then okay, so if you run this is going to run it on the console then, instead of what you want us to do, but it will basically give errors.
I forgot there was a limit on it. Maybe like a weird.
It's not going to. Yeah, you won't be able to fix it with console. You'll have to entirely change it. Okay.
Isn't that like structurally?
Yeah, it is, but I don't want to use XYZ.
Well, yes.
It doesn't give you the logic. So the first 2 terms were done. Eric, the question here is from Kash, why do you have Fibonacci 1 equal to 0, Fibonacci 2 equal to 1? Why did you stop?
Because to get the first result, like the first term or whatever, you need to be able to add something. And originally I thought it should be 0 and 0, but then if you do that, it'll be 0 plus 0 equals as the result. So you get 0 again, it would just keep going. So I did 0 to 1 so that it would go 0 plus 1, and then equals 1, and then it would equal 1 like that.
Okay, so you needed the two starting values, and the result is the sum of those two, yeah. And then he sets up the loop, and inside the loop is beta report. The user asks for the twist, so yeah, you're starting from so 0, 1, starting from 2, and the second one is less than or equal to 1 to keep going. What are you doing? So what Eric has called Fibonacci result, I had called Fibonacci number, and I guess what the reason was because he has used this. You could also, if you want to, call this first term, second term, but that's fine. So if you are going to use result, then this return is going to be result. Okay. The issue is though you need to think heavy, and so Krista figure it out. Megan, do you have it figured out?
Yeah, I haven't figured out. I really
Okay. Who else said I used to do the logic? Okay, Krista, do you want to explain what you did? If you're, you don't have to write the program. You can. What is the logic here?
For study for.
Well, you don't read out the code. You have to give me the logic.
Okay, so I
No, you can come up here. You don't have a reference to what you have. That's fine. When you're forced to explain it is when you use terms that will make logical sense. So if you were to come up to the whiteboard there, then you can write it out like a grid. So what is the logic that you're using?
I should write the code.
No, not the code, the logic. You can explain the logic. Say, you have these three variables.
I declared a new variable as I, so.
You mean for the loop?
For the loop.
Okay, well, so inside the loop you are setting up whatever you want to. Instead of I, what's the purpose of I usually?
I use it.
No, generally in a loop, when you set up I, what does
That
it
was my
say?
starting point.
Okay, the starting point, you are usually using it as an index. Okay, so I stands for, if you expand it out, it stands for index. And you can give it some starting value, either 0 or something else if you choose to. Okay, so how many of you use 0? I think Eric used 0. And that actually might work too. And then you set a stopping condition. So this is a starting condition, a stopping condition. When do you stop? At what point do you want to stop? Live? Input term. Okay, so we have to figure out if we are starting from 0, we want to stop at, so is there a 0th Fibonacci term? There's only a first term, right? So if we start from the first term, then where do we stop? We have to stop at where the input term, so which means, what do we check for here? What are we comparing?
Index needs to be less than or equal to.
Okay, so we are going up to the input term. So if I'm looking for the 7th term, I start from the first term and go up to the 7th. So one of the things you have to figure out logically is, what is the starting point? Is it going to be 0? Is it going to be 1? Okay. And then what else do you need in a loop? You have to increment, change the value. So you increment, usually increment. You can also do what? You can go in the other direction. Okay, so I'll set up the body here, and this is what the logic that you have inside the body is what I want Chris to go over the logic, not so much the actual code. What is it that you're trying to apply?
Okay, well, the logic, you kind of just have to know what the Fibonacci number is.
Okay.
So I did, like the Fibonacci number is the first, the first number plus the second number, or equals what you're looking for.
Okay.
So it's just adding up all the previous numbers.
So the result is the sum of this plus this. Okay.
Right.
So that's one step. So how do we now use the loop? So one statement is to say what you just did, this Fibonacci result, Fibonacci result is the sum of Fibonacci 1 plus Fibonacci 2. Okay. But if we have this loop set up, if we leave it as this, what will we get as our result? We'll be constantly getting 1 regardless of what term they mean.
Right.
So what did you do to really use the loop and prevent that from
So to use the loop, you need to make sure your result is going to be changing,
Okay.
so that your numbers are changing. So that every time you go through the loop, it's going to add 1 to it until you get to your input term.
Okay. So what there was something else you did inside the loop to make this logic work.
Right, so I have 3 steps. So my second step, I set the first number equal to the second number.
So when you said first number equal to the second number, you basically said this number was equal to this number. Okay, so basically that would mean that Fibonacci number 1 holds the value 1 instead of 0 the first time around. Okay, so and then what else did you do?
I forget. I know I had a third step that had the result, set the result equal to.
Okay, you're on the right track. Actually, you've reasoned through it quite well. Now, let me put it on somebody else, actually. You're out of time. How many others of you know that? I think Eric knows it, right? Who else knows this? Okay. Sally, what's that stuff? Okay, very good. Okay. So now I'm not going, you figure this out and get this working. Next class, what we are going to do is we have to test if this works or not. So do what I'm going to have you do is, Hallie gave us the last step. The very least, all the rest of you could do is to figure that out, and then do on paper, do a test. How do you do a paper test of this logic? You know how to do it, right? Write it out. So I'm going to come around to see whether you can give values, write it out on paper, the logic. And next class we will do the test using the testing project or framework that's here. Okay. But I want you to do it with some values on paper to see if it comes out to these values. Okay, and I want all of you to be at this point, beginning of next class, so that we can move on to the next stage.